Lesson 118, sine, cosine, and tangent. If we have a triangle ABC, where C is the right angle, we can call the leg opposite angle A as little baby A. The other leg would be little baby B because it's opposite B. And then the hypotenuse will be C. If we want to find the sine of angle A, so we write sine as S-I-N of A. It's still read sine of A. That is a ratio between the opposite leg and the hypotenuse. So the opposite leg from angle A is little baby a, and the hypotenuse is c. So it's going to be a fraction of a over c. Sometimes to remember it, I think of the word so. Sine opposite over hypotenuse. To find the cosine of A, to shorten it, we use 3 letters, COS. We call that the cosine of A. That's the adjacent leg. That's the one right next to angle A over the hypotenuse. So the adjacent side or leg to angle A is little baby b, and the hypotenuse is c. And I remember it by saying ca, C-A-H. So far we have so, ca. So cosine is adjacent over hypotenuse. The last one we're going to go over is called the tangent of A. We shorten that to 3 letters, T-A-N of A. That still means tangent of A. That's the opposite leg over the adjacent leg. So the opposite is little baby a, the adjacent is b, so it's this ratio of the side lengths. So we're actually just getting the side lengths, and the way I think about that is to remember that tangent is opposite over adjacent. So putting these 3 together to help us remember, we're going to do so, ka, toa. I'm going to put that down here. Toa. And this just helps us remember the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And you can do this from angle A or angle B. So we're going to do an example where we want you to find the sine of A, the cosine of A, and the tangent of A in fraction and decimal form. So we're going to have a right triangle. We're going to do this. Okay, this is a right triangle. A, B, C. We're going to say this is 6 units, 8 units, 10 units for the hypotenuse. So the sine of A. So I'm going to write so, ka, toa. So I can remember we want the sine of A. That's going to be opposite over hypotenuse. So we're going to do opposite, which is 6 over 10, reduced as 3/5, and as a fraction, decimal, it'll be 6/10 or 0.6. The cosine of A is adjacent over hypotenuse. So we'll do 8 divided by 10, which is 4/5 or 8/10. And then the tangent of A is opposite over adjacent. So opposite 6 over 8 or 3/4. And 3/4 as a decimal is 75 hundredths. So here's another one. We're going to make a 30, 60, 90 triangle. Call it X, Y, Z. So the sine, we're going to say the sine, oh wait, this is 1, 2, root 3. If you remember, 30, 60, 90 triangle has a ratio of the 1 to root 3 to 2. So the sine of 30 degrees. So here's 30 degrees. We're going to do opposite over hypotenuse. It's going to be 1/2, or 0.5. The cosine of 30 degrees is adjacent leg, so root 3 over 2, or 0.866. The tangent of 30 degrees is opposite over adjacent, so it's 1 over square root of 3, but we can't have a square root in the denominator. We need to rationalize it by multiplying by 1 in the form of root 3 over root 3. I'm going to zoom in here. So we have 1 times root 3 is square root of 3 divided by square root of 3 times square root of 3 is 3. So it's square root of 3 over 3, or 0.577. That's 2 7s. Very hard to see because I ran out of page. I don't like it. I'm going to write below. That's really the end of the lesson. There you go. Okay, end of lesson.